with great pleasure that I present Professor Fu Jun, one the most important, maybe the most important professor of economy in China. He is Dean of School of South-South Cooperation and Development at the Beijing University. He founded the very important review, the Peking University Public Policy Forum International, and is director of the program Global Public Policy Executive Education. We are really very, very pleased to have you here. Professor Fu Jun speak about AI, energy, and economy, a meta-heuristic approach. Please.
Thank you. Let me. Tinali, for your very generous introduction, and also for giving me this great honor to speak here. As a kid, I was so impressed by the great scientist Galileo, and together Galileo was among the first Lincei fellows. And I also feel very honored to be elected a Lincei fellow by this great academy as the first Chinese from a PRC. There are other Chinese, probably from the United States, but I'm the first Chinese from the People's Republic of China to be part of your great institution. And I remember as a kid when Galileo said, the universe is composed in the language of mathematics. And that has inspired me also as a social scientist to take mathematics very seriously. Today, the talk that I will do is AI, energy, economy. And much has been talked about this topic. It's a very hot topic. But if I'm going to make a contribution to this topic, what I will do is to add my theoretical framework to what seems to me separate things. I'll do a unifying theoretical framework so that I hope when we look at AI, energy, and economy, or economics, there is a difference. Economy is the phenomenon that you describe. Economics is we must have a serious theoretical framework to explain in a simple, consistent, elegant way such that you also explain with a large scope of things. The scope is larger, the better, as a theory should be driven by simplicity, consistency, accuracy, scope, and fruitfulness. Now, the name that I use to describe my theory is called meta-heuristic framework. Matter is metaphysics. You transcend physics. And I take mathematics as metaphysics because pure mathematicians do not have to operate with the real world. They can operate independent of the real world. Now, this is so amazing, but when you build a bridge between pure mathematics and the physical world, the material world, your mind would become so powerful, such that people like Einstein can see things that others cannot see. And when you close your eyes, you can see, you have an image of a cosmos, but many others cannot see. So these are the people who were the ones who were there to push the very frontier of human knowledge. And that indicates, thanks to those people, because we humans can continuously push the frontier of scientific knowledge when you have a marriage between mathematical precisions and real-world observation and let them have a dialogue. This is the ultimate source of economic growth. I will do three things, basically, three parts. The first part is Albert Einstein, even though I do social science. But I think natural scientists are very inspirational for us to do social science as well as humanity. I think mathematics is humanity because we humans do mathematics. Other animals do not do. So I take mathematics as a part of humanity. Einstein on theory, and why theory is so important for us to organize empirical observations. Now, this is the other way around. Most people do is to observation first, then they organize. Einstein, the way I read him, is the other way around. Mathematics first, then empirical observations, then a tight, very rigorous framework to organize the universe. Isaac Newton did the same thing. Newton was a great scientist, and Harley was a great scientist. But Harley is much more inductive than deductive. And Isaac Newton had a good sense of combining the two, so that intellectually, Isaac Newton was much more confident than Harley, who basically did statistical work. When Harley sees the organization of the result, it's not round, it's elliptic. He probably was not as confident. He probably was religious, and he probably wondered, when God composed the universe, right in the circle, why the circle is not perfect? But when he asked Isaac Newton, Newton was so confident. Eclipse. Because he has the power of mathematics to organize the empirical observation that he has. So at that moment, before Newton, it's basically a Kepler's way of looking at the world. It's data-driven, inductive. Whereas Newton was aware of the power of combining the two, both the deductive and the inductive. And now we humans, at least the scientists, are in a better position to penetrate deeper into the universe. So the first part is about Einstein's comments on theory and its importance for organizing empirical observation. And the second part, more relevant to the topic that we are doing today, by setting up a framework first so that we can observe the subject matter, AI, energy, and economy. Again, the three topics seems to be separate, come together. And hopefully we are in a better position to understand the three topics and their interconnections better than others. And finally, I will making comments on the three subject matters, AI, energy, and economics, driven by simplicity, consistency, accuracy, scope, and fruitfulness. This is the economics is all about. Einstein. Einstein said, the supreme goal of all theory is to make the irreducible basic elements as simple and as few as possible, without having to surrender the adequate representation of a single datum of experience. Now, you probably see from what Einstein is saying, he has two parts. On one part, actually it's mathematics. On the other part, it's the real world. And that two need to have a dialogue so that we can penetrate deeper than others into whatever we are intellectually interested in. Now, the second line that I quote from Einstein is that he said, all true theorists are sort of tamed meta-physicists. In other words, he was a physicist. And when he employed mathematics, he see the critical importance to bridging the two parts, pure mathematics and the physical world. This is so important. Many of economists, when they deploy mathematics, they forget about that. So the model they build has no relevance with the real world. Aerodablo's model, for instance, the two won Nobel Prizes, but their model turns out to be lifeless and static. And many wondered, why was the case? Is it because we used mathematics too much? And my argument to you is no. because we haven't wanted deeper still into mathematics. Now we have more powerful mathematical tools to connect two worlds, the mathematical world and the physical world. And the third line that I quote from Einstein is that he said, quite the opposite. It is our theory that determines what we can observe. I know most people do not do that way, but of course, on Earth, there are not so many people who can think like Einstein. And it's so important to understand why Einstein say that. It is not inductive, but you need to have a theoretical framework such that you can see things that others cannot see. Now, commenting about the power of the intellectual power of Einstein, based on what he has contributed in terms of scholarship, in terms of his general theory of relativity, John Wheeler said, space-time tell matter how to move, and the matter tells space-time how to curve. When we open our eyes, these are the things that we cannot see without our naked eyes. But if you have a powerful framework and you have a good sense of how space-time, the invisible hand, the cosmos invisible hand, tells matter how to move because it's curved. And why it's curved? Because it's matter that weighs on space-time. So you see the interaction between the two parts, the visible world, the invisible world. And inspired by that, if we do economics, at least we should raise the question, which is the invisible hand. We also say the market is the invisible hand, the state is not. But state sucks in so much energy. Hobbes was right when he talked about the role of a state. He used the word invisible agent. So for those of us who do political economy, at least the two parts are invisible. Invisible state, invisible hand. And now, for what I do, we need to add a third one dimension, the invisible conventional social conventions. These are invisible forces, but they shape of behavior. For all three, you add them together, you may say it's civilization. Civilization takes energy to develop and to sustain. So it all boils down to Einstein's equation, E equals m squared. Now, how do we distribute the equation is the subject matter that are indicated today so that we can see the world much better than the conventional way of doing things. And let me further enlighten the importance of theory, as well as why theory is important for us to penetrate into the subject matter that we do. Also quote John Holland. He is a great scholar doing complex studies, as well as is a great computer scientist. He said, with a theory, we can separate fundamental characteristics from fascinating idiosyncrasies and incidental features. Theory supplies landmarks and guideposts, and we began to know what to observe and where to act. And these also apply to what we do today as either natural scientists or social scientists or even humanists. Now, let me briefly sketch out the meta-heuristic intellectual framework that I use to organize the observation, the empirical evidence that we collect today, or the data, if you may. My argument is that data itself won't do the work. Data combined with the theory, then that's a powerful way. In other words, it's called theory-oriented empirical work. AI is too much on the side of induction, not enough on the side of theory. And AI pretends it can think like humans, but actually it's not. Now back to the intellectual framework that I have. Meta-heuristic growth is a high-dimensional, unifying, and a dynamic theoretical construct which models economic growth with a human cognition. Conventional theories haven't been able to model human cognition into their framework. But in this framework, I'll try to model human cognition and intentionality, because if you want to talk about economic development, does that human have the intention? Many politicians do not, probably. They want to maintain power rather than to take care of the well-being of their citizens. And we should do that in complex ecosystems. It's no longer linear. It's nonlinear, non-convex, multiple objectives. State has its objective, society has its objective, market has an objective. State is power-driven, market is wealth-driven, whereas community is friendship, or intensify that, love-driven. First principles, even though in the real world, someone wants to all have three. But to pursue the three, people invariably have a strategy. Someone will join the government first, others will join the market first, others will do as a non-government organizations. For instance, in China, even today, under the same culture, northern part of China is more pro-state, whereas southern part of China is more pro-market. And now, empirically, you see the widening gap in terms of wealth between the two parts. Even in the United States, if you live in places like Washington, or if you live in places like New York, as a kid, you ask them, when you grow up, what do you want to do? The choices will be different, because they are attracted subconsciously by the power, energy concentration that is already hidden behind those human institutions. So ultimately, the framework as a connection between the mathematical world and the real world is ultimately constrained by the classical limit of the physical laws of thermodynamics, including Boltzmann distribution and Hamilton's principle of least action. And that principle actually is much more powerful than the economists say economizing. If you are not economizing enough, here it means you deviate from the natural law. So it is mathematically formulated in Hamiltonian simple elliptic geometry. It's a much more sophisticated geometry doing complex system than Euclidean geometry or Riemann geometry, in elliptic and cusp forms. I will demonstrate a little bit later on what does that mean. Through lattice and neuron network. It's like a huge lattice, okay, to shift the evidence. The tighter it is, the more precise that you think. And your brain, consciously or subconsciously, you subconsciously or subconsciously, work that way in the quantum style. Because we live in the curved fields. If you see the combination, recombination of state marking the society, that combination, as time goes on, varies across time and space. Countries are different, and that curvature is different, and that will have an impact on the behaviors, both at the macro level and micro level, the way you think. And these are so important for economic growth. And here, I mathematically written that framework. Basically, let me show you a little bit. This part, it's natural capital, human capital, physical capital. So this is the material causes of growth. This a quantum simulation. This is state, it's vertical. Horizontal is the market. Society is diagonal, okay? figures, configures, let it spin. Imagine the ET. The configuration will be different. So the energy distribution among the three will be different. So this is the institutional cost or the institutional capital in that causal network. And this is the idea gap. And you pull up the black box of how you think, basically is a triad: induction, deduction, and abduction, the dialogue between the two. And subconsciously, you work that way. Most people can only do induction without the help of serious deductive work or mathematics. But for someone who are trained systematically mathematically, they're aware of that. So that facing a subject matter or the nature of the problem, if it's just to address real-world concerns, they probably relax logic. To tighten up, then you tighten up logic to push the frontier of mathematics. But even in mathematics itself, there are tensions between those who are more logical than those who are more intuitive. So mathematics, if you open that box, you also see tensions. And if you're aware of the tensions, you know when you want to make breakthrough, you know where to tighten a little bit, where to relax a little bit. Topology is, by the way, doing complex study is very intuitive because it wants to look at the holistic picture, whereas Euclidean geometry is not holistic, it's more reductionist than holistic. But if you're aware of both, then you can be both reductionist and holistic simultaneously. And when you move forward, and over there, you see singularities. Not a Euclidean point, by the way, because we are talking about the real world, the physical world. So this is the mathematical setup of the theory. So this is a simple illustration of what I told you. This is a setup with eclipse. If you go from the bottom to the very top, how do you move up? Then it's ecliptic moves. Okay? So it's ecliptic and cusp forms. And there you can, as a process, align historical reasoning asymptotically with the mathematical reasoning. And if you do physics, now this is a very popular model you would do. It's called Ising model. So you model it like Ising-like in simple elliptic geometry. The model, in our case, deploys transdisciplinary and a group theoretical analysis in multi-layered causal nexus, material, institution, ideational, three structured way. Material causes institutional invisible hand, that ideational, the way we think. And with an evolving institutional matrix of state, market and society at the mesoscopic level, it's a field. We systematically put it in a field, so that if you're a firm and the energy is already curved in favor of the state, and you probably would spend more time talking to state officials. If the energy has a higher level of concentration, then you say, why bother with the state officials? Stay away from us. We want just to cut deals. So 3 layers: the macro, the meso, the micro, the ideational level, with the playing field, the field, with a varying curvatures across different countries, which interact with and impacts on the behaviors at both macroscopic, for instance, a firm, and a microscopic, the way we think. If the state is so dominant, imagine a scholar. Would they write something against the state? The chance is very little. Being rational, quote and unquote. With that setup, you see the model itself has a role for entrepreneurship to play a critical role. Political entrepreneurs, economic entrepreneurs, or social entrepreneurs. In China, if you see the past 40 so years, the political leadership was very important. Imagine Deng Xiaoping. He pushed so hard from a state-dominated economy to a more market-oriented system. So in short, this is sort of a sketch of the point I was making. And now, this is another diagram for you to have a better sense of how configurations between state, market, and society, reconfigurations, reforms, if you may, will make a difference. And then I put a theta here. It's the angle. If the angle is larger than 45, then the system is more pro-state, given the same amount of energy, enclosure, okay? State, market, and society. If the theta is smaller than 45 state, it's more pro-market. In China, roughly speaking, now it's in between. Big numbers, okay? The non-state sector now contributed 50% in terms of taxation, 50% in terms of taxation, 60% in terms of GDP, 70% in terms of innovation, 80% in terms of employment, 90% in terms of number of firms, almost from scratch 40 or so years ago. So you see the energy distribution behind the invisible hand, the invisible agent, the invisible hand, the market has been changed so much, and that is so powerful for us to explain and to predict how China will continue to perform economically, and now, hopefully, in the future. As you can see, with this diagram, our approach is group-theoretic and transdisciplinary. It will involve political science. We're talking about the state. Economics, we're talking about the market. Sociology, society. History, because if it's a four-dimensional model, 3 dimension plus time, you need to have a history line, plus cognitive science. In that time tunnel, how our brain operates, human conscious cognition, deductive, inductive, abductive. How tight should we be in terms of logic? By the way, economists are wrong to assume that we maximize. We do not maximize. We just want to survive. Good, to be good is good enough. Okay? But with that, we can calculate very quickly. Incidentally, our brain is the most efficient computing machine on Earth, consuming about 20 watts of electricity each day for so many things that we do. Now the AI consumes much, much, much more for the same thing that a human do, even though it seems to be more powerful, but it consumes much more energy. Information is energy. Think anti-entropically. Life is an anti-entropic machine, the same thing, everything is energy. Now to demonstrate, physically demonstrate the connection between the two, between wealth and energy. Economists say it's wealth, the GDP, but if we look deep as a physicist do, it's energy. Now, thanks to my friend Cantucci, who is a professor at Bologna University, he did a long-term test, empirical, between energy consumption and economic performance. And this is what you get. The R square is over 95%. So for the measurements and what have you, the two things are almost the same. Now, with scholarly contribution, scientific knowledge, if you think of Boltzmann distribution and Hamilton principle of the action, This makes a lot of sense. So we should take energy very seriously. And that, in a way, mathematically addresses Hilbert's question, because Hilbert was arguing, if mathematics, when we come up with theorems, then axioms and the theorems, then we are so confident it's true, then you map that out into the real world, the physics. And hopefully you would have at least very approximate conclusions. So for us to have a framework with a mathematical context of justification, then descending down a little bit, physical context of justification, then descending further down a little bit, a historical context, and you align the three together, you have a very powerful intellectual framework to organize whatever you observe. And with that mathematical framework, plus physics, plus human environment, the ultimate question, if you do simple elliptic geometry, is in each modeling is what manifolds L admit Lagrangian embedding through immersion into 3 raised to the power of the n by lattice, or lattice means it's a physical, mathematical physical, and the neural network means it's a biological. Our brain is biological. Now AI is mathematical, physical. Not physical yet. AI is informational. It's yet to understand the physical world. So at this stage, AI is informational, not yet physically intuitive. Down the road, hopefully it can also be biological, so that it can be very powerful in terms of computing with a limited amount of energy. And relate to that concept in economics is efficient through economizing. And for me to carry out that work, the concept is economic productivity of energy, so that we can link all things together. Now, with that framework, it's easy for us to sort of making comments on AI, or you sort of read newspapers, read other research report, and to sort of pose even deeper questions than energy, than economy. Are we doing good enough? If you look at the 200 or so economies in the world, which one is ahead, who is emerging, who is still ahead of that, the product, which one is the highest, which one growth rate is the highest, or what's the prospects of that economic growth rates. And ultimately, it has much to do with the field, the academic field of economics. Are we in a better position than the conventional way of doing economics to see deeper, such that we can both explain and predict than the current model of economics? So the first point, in modeling economic growth with a human cognition and intentionality in complex ecosystems ultimately constrained by the classic limits of the physical laws of thermodynamics, meta-heuristic growth approach beats neoclassic economics. Neoclassic economics is low dimension, stay in the market, not high dimension. In our way of doing things, it is high dimensional. It's 4 dimension, state, market, society, plus time. Then it continues to evolve. And in doing so, it's almost as if we are answering to the challenge of Hilbert's 6th problem. He was asking, is it possible for us to map the mathematical way of things into the physical world? And in our case, map further into the social, human world. Now, if we are successful, and we are in a way, and the new approach represents a paradigm shift from classic economics, and it can serve as a high-level theory-oriented, solving algorithmic framework that provides a set of guidelines to develop heuristic optimizing strategies. As I indicated early, in our network, 3 layers. The first layer, it's the material causes: natural capital, human capital, physical capital. The middle level, state, market, and the society, the meta level. And the third level, the micro level, the human, the way we operate, the ideational sources. 3 key variables: induction, deduction, abduction. And this is a causal network given the same amount of energy, how the energy is sort of distributed to come up with the best answers in that non-convex. It's multiple goals. It's not a convex system. And who is doing better than others? So if we move down to the microscopic level of ideational sources, because I say that, I highlight that, it has much to do with AI, the topic of AI. The first set of comments has much to do with economics. Are we in a better position to do economics and the conventional? The second one has to do with AI, because AI mimics how humans think. As the ultimate engine of economic growth, in line with Boltzmann's contribution and Hamilton's principle of least action, it's energy, consuming about 20 watts of electricity each day. Okay? And by the way, much of our brain is not rational. In English, you have 3 words: logical, psychological, then biological. Okay? Our brain is all 3: logical, psychological. The logical part actually is very small, probably. Very psychological and the biological. And in light of the triad of the human recognition and intentionality, now if I'm going to operate in that curved field, state, market, and society, okay? If the energy is already curved much in favor of the state, I probably would say to join the state is my best choice, intentionality, okay? Even when the country is small, why change? I want to keep my own power, okay? So, as attention as you can imagine, political leadership is so critical for a country to reform. Entrepreneurs as well. So in our brain, it has a triad of induction, deduction, abduction, with activation/annealing functions in quantum computation. Now we are aware of that. And in the current approach to AI, as humans develop AI as an agent, okay, we are still the principle. AI is not just tool, at least it's claimed, but as an agent, okay? It has some degrees of autonomy, but as creative as the human mind as an agent. So principle, agent, and the tools. AI is classic rather than quantum, the way they calculate. Digital rather than analog. Our brain is analog. Okay? Our brain is quantum. Inductive and data-driven rather than theory-oriented, at least for the brilliant human beings, to say the extreme, Einstein. Theory-oriented, as I quoted early, and he said it's so important. He said, imagination is much more important than knowledge. What AI fundamentally is based on, a stock of knowledge, though so large a stock, and the individual cannot beat the AI, but it's inductive, not creative in terms of theory. And because of that, AI is hugely inefficient in terms of EPE, relative to human brain. It consumes so much energy to kill a mosquito in a way. But for a powerful human brain, you use so little to address so many interesting things as Einstein did. And by the way, our brain is still the most efficient computing machines on Earth. But as I argued, our theoretical framework, meta-heuristic, is principle/agent-based. If for us to combine the two, principle with the agent, then what we can predict is years down the road, the speed will up many, many times in terms of doing scientific research to penetrate deeper into nature or into life. But there are some concerns about AI. Unless we synchronize its development well enough, AI, with CO2 emissions neutrality targets, okay? Because it consumes energy so much. Before we were able to transform our energy structure from fossil to non-fossil, then if AI uses so much energy, it is problematic because climate change is also an existential threat facing humanity. So the current seemingly irrational exuberance of AI has potentially negative allocative and distributive implications for climate change. And it is very important if we think collectively, United States, China, the big powers, to balance both the development of AI and also the serious concerns of climate change. If we do not have a good balance, then a blind pursuit of AI, much more in competition than in cooperation, will put mankind in jeopardy. And this is a particular case when currently we all know fundamentally the world system is a system that is anarchical. In other words, there is no central authority. And if for a country just to take a position of winner takes all, it's very dangerous with the help of AI as an agent, even though it is not a principle yet. Because imagine if it gets militarized, the danger is so great, probably greater than nuclear weapons because it's so decentralized, whereas nuclear weapons is so much centralized. So in terms of command and control, probably it's better to manage. Three sources of concerns of AI. One is, as I mentioned, what if it gets militarized? The other is, what if the principal is a bad guy? Then the third one is, what if the agent becomes a principal? And all these would raise concerns, and it is so urgent for us to think collectively and hopefully to act collectively, to raise awareness globally, and to project forward. If we use our meta-heuristic growth now plus spin glass theory, so many things, you spin, okay. You see clustering around of different countries. That's how the physical world works. Now, if it says anything, indicates anything, probably years down the road, with the tension of geopolitics going on, rather than you see a prospect of conversion, we probably will see a prospects of divergence. And that itself also calls for leaders, intellectual leaders, to raise those questions, concerns, and hopefully raise the awareness of people so that we address those concerns collectively for the benefits of the whole mankind. Thank you very much for listening. Thank you.